AC703 Modbus R2 product. Debugging process. 1. Principles of data acquisition and hardware preparation. 2. Hardware wiring demonstration. 3. Software introduction and parameter configuration. 4. Practical demonstration. 1. Data acquisition principle and hardware preparation. The device uses three RS485 interfaces. It actively pulls and connects to the sensors on them. It regularly obtains data from the sensors and performs parsing and processing. The sensor protocol can be either standard Modbus or a custom protocol. The processed data is stored in real time into the device's internal mapping area and encapsulated according to the user set protocol. It is automatically sent to one or more target servers via the 4G or Ethernet uplink network channel. Up to 4 target servers can be configured. Hardware preparation. AC703 terminal block, 4G antenna, Type-C configuration cable, DC 12 volts power supply, SIM card, network cable for LAN access, 485 sensor. Regarding network connection, you can choose one of the two options based on the field situation. If choosing 4G mobile network, a 4G antenna and SIM card are mandatory. If choosing wired network, please prepare a network cable connected to a LAN. 2. Hardware wiring demonstration. First, connect the device to the sensor or collector. Here, the AC104 vibrating wire collector is used as an example for wiring demonstration. The wire sequence for the vibrating wire collectors 485 and power is yellow wire 485A, white wire 485B, red wire VC, black wire GND. The yellow wire 485A and white wire 485B are connected to the A and B terminals of AC703's first RS485 interface respectively. The physical interface here must match the interface selection in the subsequent software configuration. For example, the first 485 physical interface is connected here. Regarding power connection, therefore, in the software interface selection, you need to select RS4851. The red wire VC is connected to out 12 volts. The black wire GND is connected to the GND terminal. This allows the AC703 to directly power the collector. If the sensor has its own power supply, the red wire can be omitted. Then install the communication module. Network selection can be either 4G or Ethernet, or both can be used simultaneously. Here, both networks are connected for demonstration. The IAT SIM card has been inserted here. Then install the 4G antenna. If not using 4G, it can be omitted. Connect the Ethernet cable that is already connected to the network. If not using Ethernet, the network cable does not need to be connected. For local configuration, connect to the computer via a Type-C data cable. Finally, connect the power supply. After powering on, confirm the status via the indicator lights. The power light being steady on indicates normal power supply. The 4G light being steady on indicates the SIM card is recognized. The Ethernet port's yellow light steady on and green light flashing indicate the link is active. At this point, the wiring is complete. 3. Software introduction and parameter configuration. For setup software, please contact customer service or support personnel. Step 1. Install serial port driver. Open the downloaded configuration software. Find the serial port driver. Find this application and click. Keep clicking next to complete installation. The subsequent steps will not be demonstrated. The serial port can be emulated via the configuration cable. Right-click this PC. Click Manage, Device Manager, Ports, to check if the serial port driver is installed. Software connection device operation. The AC703 device has two setup methods. First, connect directly to the computer via a serial configuration cable for setup. Second, remote setup via TCP protocol. Remote configuration requires the software to run on the connected external server. Fill in the corresponding port. For initial configuration, you need to use the serial port connection first. Select serial port mode here. Select the COM port emulated by the serial cable. Keep the baud rate at the default 115,200. Open the serial port. Click Read All. If the print area shows Read Parameters Successful, it proves the device is successfully connected to the computer. Interface Parameter Configuration. This corresponds to the 3 downlink 485 ports. The default baud rate for the serial ports is 9600.no parity. Special attention is needed here. The parameters for each 485 interface must match the parameters of the connected sensor. Otherwise, data from the sensor cannot be collected. Next is the Ethernet configuration area. If the sender transmission uses Ethernet to transmit data, this needs to be configured here. If the network connected by the cable has automatic IP assignment function, then check DHCP to let it assign IP automatically. If it cannot assign automatically, manual configuration is required. Enter an IP in the same network segment. This IP address must not be duplicated with other devices in the network. Otherwise, it may cause IP conflicts, leading to abnormal network communication. APN is a parameter for 4 grams network access. Different operators have different APNs. The device will automatically recognize the APNs of domestic operators. Collection interval is the time for the device to collect sensor data and upload it to the cloud each time under normal state. Unit is seconds. The device address can be set by yourself. In TCP data transmission, this device address is used to distinguish the device. Alarm cycle is when the device collects sensor data and calculates that the sensor data exceeds the alarm value. At this time, the device collects sensor data and reports according to the alarm interval. Until the alarm is cleared, then it reports according to the collection cycle. So when setting the alarm cycle, the value should be less than the collection interval. UTC time offset indicates the time difference between local time and UTC. Positive offset means addition, negative offset means subtraction. For example, Beijing time is UTS plus 8. Select positive offset of 8 hours. This is the overall process of setting how the device collects sensor data, performs value conversion and parsing, and sets corresponding alarm rules. Interface selection. There are 3 interfaces to choose from here, corresponding to the 3 485 channels of the downlink interface. The selection here must be consistent with the wiring position. Otherwise, data collection will fail. If close is selected, this channel is not activated. Element name can be set by yourself, up to 12 characters. In MQTT protocol transmission, it is defined in JSON format. Then the element name is the field name in the protocol used to define the channel's data. Element code in TCP protocol is used to distinguish sensor data, so each channel needs a unique code. The element code is 2 bytes. The software filling is in hex format. When uploading via TCP, each channel occupies 6 bytes. The first 2 bytes are the element code. The next 4 bytes are floating point data. Conversion method. Conversion parameters the data collected from the sensor, and conversion parameters are relatively converted. This setting is made according to your own sensor characteristics. The uploaded data will be the converted data. Here is the setting for the communication instruction between the device and the sensor. It can be Modbus or custom protocol. If it's a custom protocol, check the custom option. Sensor instruction 010310000002 is Modbus R2. Read instruction. Instruction breakdown. 01 is device address. 03 is read holding registers. 1000 is the starting address. 0002 is the number to read. This instruction needs to be modified accordingly according to your sensor manual. There is an additional option here. Pay attention here. if you read multiple sets of data from the same sensor via one command, as long as the previous channel reads the data. By checking additional, this channel cannot send a collection command and directly use the data read by the previous channel for parsing. The first channel cannot check additional. Below are the settings for obtaining data and parsing data. Combination method is used to define the parsing rules for the data returned by the slave. The specific byte order and format need to be determined according to the Sensor Communication Protocol Manual. Precision. The formula here is display value equals original value multiplied by precision. Offset starts from 0. If the offset equals 3, it means starting from the 4th byte of the response frame to extract valid data. Intercept length equals 2 means starting from the offset position, continuously extract 2 bytes as valid data. After configuring one collection cycle as above, the device will send the instruction 010310000002 to the sensor. Assume the sensor's response frame is 010304549012378888. According to the above parsing configuration, offset 3, intercept length 2. Intercept the data 5B49. Combination method is double byte AB, meaning 2 bytes are combined into a 16-bit. Data in the order of high byte first, low byte last, combined into a 16-bit data, get hexadecimal. Value 5B49 corresponds to decimal value 23,369. Precision equals 01, that is, the parsed value equals 23,369 times 0.1 equals 2,336.9. If the combination method selects double byte BA, meaning low byte first, high byte last, then the extracted data is parsed according to the combination method, get hexadecimal for 95B. Its parsing logic is similar to the combination method, both based on the selected order. To reassemble bytes, corresponding decimal 18,779. Precision equals 0.1, final result 1,877.9. Alarm parameters are used to set the trigger conditions and preset values for data alarms. When the sensor data meets the set alarm conditions, the device will automatically trigger the alarm mechanism and report data according to the alarm cycle instead of the regular collection cycle until the alarm state is cleared. Sender parameter configuration. Next is the configuration of sender parameters. This part mainly configures the server parameters. The device supports reporting data to up to 4 target servers simultaneously. Each sender can be independently configured with different network protocols and IP ports. Supports domain names. For a sender to work normally, the 4 parameters IP, port, network selection, and platform selection must all be correctly configured to be considered enabled. If using MQTT protocol to upload data, then MQTT platform parameters need to be configured. The publish topic can be customized. Pay attention to the format correct. Subscription topic should follow the topic matching rules. Username and password here are consistent with the ID assigned and password set. When the MQTT client is registered, client ID can be set by yourself, but it must be ensured that the client ID of each device is globally unique. The client ID will be displayed in the second line of each data packet. Sender retransmission refers to the function that when the device fails to send data due to network abnormality, when the network recovers, it will automatically resend the unsuccessfully uploaded historical data to the server. Checking the box indicates enabling the retransmission function for this center. Not checking indicates disabling the retransmission function, only reporting real-time data. After writing all parameters, click Write All, and the print area will display Write Parameters Complete. Then click Reboot. After restarting, the parameter configuration is complete. 4. Actual operation demonstration. TCP data demonstration. On the configured TCP server, use a network debugging assistant to listen to data. Just select server mode, then fill in the corresponding port. After one collection cycle, the server will receive data from the device. The specific protocol parsing is in Chapter 8 of the AC703 product specification. MQTT data demonstration requires the use of an MQTT client. Open the MQTT client, configure the MQTT server's IP and port. If the MQTT username and password are configured on the device, they also need to be configured in the MQTT client. After configuration is completed, click Connect. Click Add Subscription, fill in the published topic just configured here. It has already been added here. Data sent by the device will be received here. The specific protocol parsing is in Chapter 8 of the AC703 product specification. The above is the overall debugging process of AC703.